Calculators away. Calculators away. Calculators away. My friends, today we are going to do what we did last class, but no calculator. By the end of next class, you will be able to produce the same result as your calculator when you would type into your calculator the cosine of 2 pi over 3. You guys at the end of next class will be able to say, oh, this semester that's easy, -1/2. Okay? You ready to do that? Like, where the heck did that come from this semester? We're going to get there, one step at a time. Now, what's going to be great about doing trigonometry without a calculator is that we don't have to worry about any angle. Okay? It's impossible. We're going to focus on specific angles. And we are going to focus not on like finding angle measurements, like what is X here, but rather like here is the angle measurement. What is the sine of X? What is the sine of that angle? Okay? So we won't have to worry about the sine of, pi over 7, because pi over 7 is a weird angle. It's not a nice number. I'm not going to know how to get that answer. Okay? So it's only going to be specific things. Got it? So I'm going to make life easy on you. You don't have to worry about crazy degrees. Okay? Here are the two things you need to be prepared to do to be able to answer at the cosine of 2 pi over 3. And I'm going to ask you this question next class is -1/2. Okay? First thing is we're going to focus our attention on two triangles that create 3 different angles that we're going to worry about. Okay? The first triangle is a 45, 45, 90 triangle. Now, if you have a 45, 45, 90 triangle, what type of triangle is that? False, but close. Isosceles. We will have a shorter side that's the same as the other side and a longer side. Okay? Cool. We will also worry about a 30, 60, 90 triangle oriented 2 different ways, but we'll start with just that. We'll start with this tall orientation where we have 60 degrees on the bottom. Okay? Now, you guys remember when we first introduced radians, where radians came from? Where did 2 pi come from? Where did 2 pi come from? Where did it come from? Clock? No. It came from, 360 is a man-made number. 2 pi is not a man-made number. Came from a circle. Tell your neighbors, what kind of circle gave us 2 pi? And what about the circle gave us 2 pi? I got to remind y'all, a radian is a distance around a unit circle. What is another word for distance around a circle? Tell your neighbors. What is the formula for the circumference of a circle? 2 pi r. Circumference of a circle is 2 pi r. if this is a unit circle, we say the radius is 1. Cool? So all these lengths here, 1, this length out here, that's 1. Cool? That way we get c equals 2 pi. The distance around a unit circle, 2 pi radians. Where does 2 pi come from? It's the circumference of a circle with a radius 1. You got that? Now, what we're about to do is take our friend, the triangle, and place it inside this circle. Like that, just like we've been doing on your quiz today, right? What is the angles that I care about? This reference angle with the x-axis. Cool. Now, no matter where I draw my triangle, reference angle always here, what is consistent about every single triangle? That's not a triangle. What's consistent about every single triangle that I'm drawing? Tell your neighbors. You got a 90-degree angle, sure, but besides that. Sure, the theta is always the reference angle. That's what we've been talking about. It's a very important theorem that says, like, if you're trying to find, the trig function of this angle, it's the same as the trig function of the reference angle. We're keeping that in mind. What else do I know? What do they all share besides the reference angle and a 90-degree angle? Hi.
So I'm not too sure about the one in quadrant 3, but they all do seem to be touching the circle.
Yes, let's pretend they're all going to the circle. Yep, good. That is what's going to lead you to what they share. What do they share? Rackson. Okay, this is very important. The hypotenuse of all of these triangles is 1. Got that? Got that? Got that? They all share the same hypotenuse length. Now, do we ever consider a hypotenuse in an xy plane to be negative?
No.
No. It's all distances coming from the origin, so positive 1, no matter where we're going, all these hypotenuses are positive, okay? Cool. Got that? So guess what? Go back. Not here. Here. I'm going to say the hypotenuse is 1 for this special triangle, okay? This is 1. Now, I am going to help you find the other 2 side lengths of these triangles. And you guys actually probably are familiar with these triangles, right? The 45, 45, 90 and the 30, 60, 90. You probably have learned like formulas to help you find side lengths. We're going to just do it a different way. We're going to prove it, okay? All right, so if the 45, 45, 90 triangle, we have 45 and 45, A and B have to be the same, right? Cool? Cool? So this is really just like A. You guys know the Pythagorean Theorem, right? All right, here we go. Let me set it up. A squared plus B squared equals C squared. Hold on. I put C as 1, so let's just change that to 1. I changed B is just the same as A, so I got A squared plus A squared equals 1. Solve that equation for me for A. What's A squared plus A squared? 2A squared, Narayan. Good. What do I do next? Divide by 2? We did this one class. What do I do next? Square root? Cool. You know what? I'm going to simplify this to be root 1 over root 2. I'm going to make that 1 over root 2. I'm going to rationalize that to root 2 over 2. If you have a 45, 45, 90 triangle and C is 1, A is root 2 over 2. I just proved it to you. Cool? Cool? They're the same. Root 2 over 2. if the hypotenuse is 1. Okay, now let's do a 30, 60, 90 triangle. The proof is a little bit different. I'm actually going to use a little bit more space. And if you fit it in, great, but I need more space. All right, so we're going to assume this is again, a right triangle. What's going on? A right triangle where the hypotenuse is 1. So let's go ahead and label the hypotenuse as 1. This is 60 degrees, and this is 30 degrees. Cool. I'm going to label this as A and this is B. Now, for the purposes of getting the values that I'm looking for, I'm going to put another triangle that's the exact same triangle, just reflected over like the leg B. And I get this is A. Okay. Now, when I did that reflection, what is created if you combine both triangles? A bigger triangle. What kind of triangle? An equilateral triangle. What you were saying earlier. This must be 60 degrees here. This must be 30 degrees here. Which means these side lengths have to be the same. 1 has to be equal to A plus A. Cool? Okay, A's got to be a half. Okay, find B. Find B. Because this is an equilateral triangle. Boom, 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 boom. Which means this side and this side have to be the same length because it's 60 degrees all around. So 1 has to equal A plus A. Cool. How do I find B? What's the setup to help me find B? Pythagorean Theorem. Nice guy. You're thinking like a mathematician. A squared plus B squared equals C squared. But we already know A is a half. We don't know B. We already know C is 1. Cool? 1/2 squared is 1/4. Subtract a fourth. B squared is equal to 3/4. Square root. B is equal to the square root of 3/4. But I'm going to simplify that to the square root of 3/2. Ready, guys? You are going to be using these triangles frequently. 1/2 √3/2. Now, what's bigger, 1/2 or √3/2? This is a good question. Tell your neighbors, what's bigger, 1/2 or √3/2? And why? What's bigger, 1/2 or √3/2? This is very important. What's bigger, √3/2 or 1/2? √3/2. Why? Because √3 is bigger than 1. Right? Do you know what √3 is approximately, anybody? 1 point something is correct. 1.7. Okay? So if √3 is bigger than 1, then √3/2 is bigger than 1/2. My friends, it's important to understand √3/2 is the longer side of our 30, 60, 90. Our longer side, somebody could have said, I know that's longer because it's opposite my 60-degree bigger angle. Bigger angles produce longer sides, right? What's the biggest side? The hypotenuse. Opposite the biggest angle, 90 degrees. There's a longer side, there's a shorter side. Okay. Now, I also want to be okay with drawing the 30, 60, 90 so that the 30-degree angle is on the bottom. Okay? All right, label your side lengths of a 30, 60, 90 with a 30 on the bottom. There's a longer side, there's a shorter side. You can visually see it, right? Okay. Step one into telling me that the cosine of 2 pi over 3 is negative a half is knowing these triangles. Got it? These triangles actually kind of have to be memorized. I don't want to tell you to memorize a bunch of stuff. I'm going to try to keep it to a minimum. You guys already know SOHCAHTOA, right? Would you have said you memorized SOHCAHTOA? No, you like know it now. We're going to get to the point where we just know these triangles. It's not something that's like memorized. So we labeled this as 1/2, the shorter side, opposite the shorter angle. This is root 3 over 2, and this is 1. Cool? All right, cool. Well, the next thing that we need to do is be comfortable finding radian measurements on a unit circle, on a circle, without the use of a calculator. Okay? So now we're going to flip over to this guy. This is part of your homework. We're not going to do all of it. It's stupid. I don't think it's that stupid, but we're not going to use it, okay? Because you're going to be better than this and you're going to understand this stuff. Got it? So we are going to focus on the angle, okay? Now, what I'm going to tell you right now is that this angle right here, that's 30 degrees. Okay? 30 degrees away from the x-axis. All of these angles, first angles, are 30 degrees away from the x-axis. Okay? Now, the second one, that's going to be 45 degrees away from the x-axis. Okay, we're starting with degrees, but then we're going to switch over to radians. The last one is going to be another 30 degrees away from the first 30 degrees. 60 degrees, right? These are angles that are like, okay, we got these angles. We're familiar with these. So I wish I had a different color. I guess I'll go back to red. So this is 60 degrees away. I wish I had like green or something. Notice, it's all in reference to the x-axis. I'm not talking about angle measurements with the y-axis, right? Why do I talk about that? Because of the theorem that we've used that says the trig function of an angle, if that angle is obtuse, is the same as the trig function of the reference angle, where the reference angle is created with the terminal side and the x-axis. Okay, so I don't care about the y-axis, which I'm not caring about the y-axis. All right, cool. Now, we are going to make sure we understand all the radian measurements that create all of these locations. All right, so starting with an angle of 0, which is a radian of 0. Where does that start? Use your hands. Where's 0 start? Where's 0? Where's 0? Good. 0. Boom. 360 degrees. What's that in terms of radians? Good. All right. So everybody, here we go. We got 360 degrees is 2 pi radian. What's 180 degrees? We know that, right? Because you just take 2 pi divided by 2. You take the circumference of a unit circle divided by 2. What's 30 degrees? pi over 6. Take 180 and either divide it by 2 and then divide it by 3, or take 180 and divide it by 6. Is that cool? What's 60 degrees? What's 45 degrees? Good. All right. So we know 30 degrees, pi over 6. 45 degrees, pi over 4. 60 degrees, pi over 3. What's 90 degrees? Pi over 2. Okay? Now, what I'm going to show you is the way that I get all of the other angles in their location. Okay? And this is what you need to get to in your head so that you don't have to convert radians into decimals. And I've already showed you this one. That's Mr. Mester. But he's 6, so it's cool. All right, ready? We know 60 degrees is pi over 3, right? What's this angle here? Well, it's 60 degrees away from pi, right? We know this is pi. Now tell me, which way is adding angles in your unit circle? Show me with your hand. Which way is adding angles? That way. Okay. So, counterclockwise, adding angles. That means if we go past pi, you got to keep going counterclockwise to add angles. You guys are cool with that? Opposite direction, we go in a negative way, or we would consider that like subtracting angles. Cool? So if I went in a clockwise direction, we are subtracting angles. I know pi can be written in so many different ways using common denominators. You can write it as 3 pi over 3, for instance. Well, I could take 3 pi's over 3, subtract the pi over 3. Subtracting going this way, I'll go 60 degrees away, boom, 2 pi over 3. 3 pi over 3 minus 60. Do I have to convert 2 pi over 3 into an angle to know that 2 pi over 3 is 120 degrees? No. All you need to know is that it's 60 degrees away from the x-axis located in the second quadrant. Is that okay? Is that comfortable? Okay. Well, if this is 45 degrees away from the x-axis, what is its radian measurement? See if you guys can figure that out. Discuss with your neighbors. If that's 45 degrees away, and 45 degrees is pi over 4, you guys are pretty good at that. What is that measurement? I need to subtract 45 degrees from pi. What'd you get? Come on, you can do it. Don't give up over there in the corner. Urban, if I'm 45 degrees less than pi, I can take pi and subtract pi over 4. What's pi minus pi over 4? You know what? It's tough to do without a common denominator, right? Okay. So what can I write pi as? I already wrote it as 3 pi over 3. What else can I write pi as to maybe help me subtract pi over 4? 4 over 4 is the same as 1. 4 pi over 4 is the same as pi. Ward, what's this radian location? Good. 4 pi over 4 minus a pi over 4. All you need to know is how to get there, but you're not going to convert anything. Cool? What's this radian location? How'd you get that, Berry Hill?
You can make pi 6 pi over 6, and the 30 degrees is pi over 6 to subtract it.
30 degrees is pi over 6. Take pi, subtract pi over 6. 6 pi over 6 minus pi over 6. 6 pi over 6 is the same as pi. 6 pi over 6 minus 5 pi over 6. I'll show it right here. 6 pi over 6 minus pi over 6. 5 pi's over 6. You will be able to understand, hey, I know where 5 pi over 6 is. It's 1 pi over 6 less than 6 pi over 6. It's 60 degrees away from pi in the second quadrant. Sorry, 30 degrees away from pi in the second quadrant. Okay, smarty pants. What's this radian, and this radian? Nice, Teal. Nice, Slavin. If you know pi over 6 is 30 degrees. If you know pi over 4 is 45 degrees. If you know pi over 3 is 60 degrees. All we need to do is add pi over 3, add pi over 4, add pi over 6. You're on your way, crayons. Add. 30 degrees is our first angle. Add pi over 6 to pi. Nice, Raina. Is it Raina or Rania? Rania, sorry. The Guzman. Thank you. You can't add that like that. You don't have a common denominator. You want to add fractions? Tell me. Tell me. Alan, add 1 and a 6 together. What's 1 plus 1 6? Hassenfratz. No! We don't like mixed numbers here in this math class. Give it to me in terms of a improper. There's nothing improper. Good. How'd you get that? Common denominator. 1 is the same as 6 over 6. Add those together, you get 7 6, right? Well, what I just did was an example of pi plus pi over 6. Get this, Alan? I turned, Hasselfeld turned 1 into 6 over 6. I could turn 1 pi into 6 pi over 6. 6 pi over 6 plus 1 pi over 6 gives me 7 pi's over 6. My friends, we are located here. 7 pi over 6. I added pi over 6 and 6 pi over 6. What's the next one? Kutzler. How'd you do that? That's it. Take pi, which can be written as 4 pi over 4, add 45 degrees, you get 5 pi's over 4. We're just adding fractions here. That's it. Scott, what's the next one? Scott, what's the next one? Scott, what's this one? 60 degrees away from the x-axis here in the third quadrant. What? Wake up. Rex, help him out here. How'd you get 4 pi over 3, Rex? You add pi over 3 to 3 pi over 3. We know this is 3 pi over 2. Ooh, this is tricky. What about these last 3? Ooh, we can subtract it. Now, we could subtract it from 0 and say this is negative pi over 6, negative pi over 4, negative pi over 3. But that's too easy. So I want the obtuse angle that's between 0 and 360 degrees. That's between 0 and 2 pi radius. Well, you know what? I'll give you a hint for the first one. If I need to go all the way around to get to this angle, I can go all the way around to 2 pi and then subtract 30 degrees. I could do 2 pi minus pi over 6. Come on, fraction experts. What's 2 pi minus pi over 6? Discuss with your neighbors. You can figure it out. 11 pi over 6, because 2 needs to be over like a 6. You got to multiply the top and bottom by 6 to be 12 pi over 6s. Subtract, you get 11 pi over 6. Okay? 11 pi over 6. You will be able to get there without converting things. All right. What's the next one? We'll need to subtract 45 degrees from 2 pi. We will need to subtract pi over 4 from 2 pi. Barry, I'm coming to you. Beautiful. 8 pi over 4 is the same as 2 pi. I don't want the pi over 12. I want the pi's over 4. Change 2 into 8 pi over 4. 8 pi over 4 minus a pi over 4. Boom, 7 pi over 4. Solis, what'd you get for this guy?
I got 5 pi over 3.
Very good. Heinz, what's up?
Why is everything divisible by 2? Square root of 2 divided by 2. Square root of 3 divided by 2.
I mean, because for these triangles with hypotenuses of 1, that's what they ended up being. Using the Pythagorean Theorem, we proved what the side lengths are.
Okay, so why is it all over 2?
Well, it's got to be shorter than 1. We know that because 1's a hypotenuse. Literally, just go. If you go through the proof, it's just like that's what it is. Like, what's pi? Why is pi 3.14? Well, if you take a circumference and divide it by the diameter, you get 3.14. Just some things in math just happen. This is happening. Those side lengths of that triangle just happen. Okay. Now, ready, guys? You ready? What do you notice? Everything simplified to be a pi over 6 is just 30 degrees away. 30 degrees away. Everything simplified to be a pi over 4 is 45 degrees away. Everything simplified to be a pi over 3 is 60 degrees away from the x-axis, the reference angle. Okay. Thinking about what we just did, going to the homework assignment that I'm giving you, the Messner homework assignment. This one. Don't look at what you just did, what you just created. Flip it over. Flip it over. Don't look at it. Don't look at it. Where's 5 pi over 6? Heinz, you gotta pump the brakes, bud. Everybody's working on this right now. Wait. Just wait. Okay, 10 minutes. We're good. Okay, here's the things I keep in mind. Going counterclockwise is adding. Think about your arms. Adding. Subtracting. Okay, keep that in mind. It's 1 pi over 6 away from 6 pi over 6's. Where is it? What's the reference angle created? Tell your neighbors. Perfect. What's the reference angle created? No. Well, sure, I'll take that. But just give me degrees for the reference angle, because that's important. So, this is 1 pi over 6 less than 6 pi over 6, right? Boom. What is this? 30 degrees. I keep telling you for all your quizzes, I'm like, give me the reference angle. Now, let's pretend this is a triangle. And this doesn't like go on forever and ever. Let's pretend it stops. Let's pretend it's a triangle with the hypotenuse of 1. It must be a 30, 60, 90 triangle, right? Drop this side length down. Draw the right angle if you want to. Now, in a 30, 60, 90 triangle with hypotenuse 1, the side lengths are either 1/2 or √3 over 2. We will know this. Label the side lengths of this triangle. Remembering that √3 is bigger than 1, so √3 over 2 is bigger than 1/2. Just the reference angle. This is the correct location. It's 30 degrees away. Murdoch, what do you label the side length as? You know what? I love it, but it could be a little bit better. Barry? Sorry, Barry. Write it down somewhere. Almost excellent, perfect. You're already excellent, but I need it to be excellent, perfect. You know what? I'm going to label something different. Dario. Oh, yep, you're right. You remember on the x-axis, we're going to the left. We just had some quiz questions where we worried about that. Going to the left is negative, going up is positive. Cool. All right. This is all I want you to do. Right? That's all I want you to do. I want you to find 3 pi over 4. Go. And then I want you to drop down a line, creating a triangle with a hypotenuse of 1. And I want you to label the side length of that triangle that you just created with a hypotenuse of 1. Paying special attention to directions traveled on the XY axis. You're doing this without a calculator because you're better than that and because you have to do it. Scott, 3 pi over 4, where is it?
2 pi over 4 is 1/3 pi.
I don't care about that.
It's a 45, 45 triangle.
45, 45, 90, in what quadrant? Second quadrant. That's what I care about. I care about this is 45 degrees or a pi over 4 less than 4 pi over 4. It's a 45, 45, 90 triangle in the second quadrant. What are the side lengths of said 45, 45, 90, Scott?
It would be on the vertical. It would be 2 square over 2.
Root 2 over 2. Yep.
Yep. And then root 2 negative 2 over 2.
Good. Which one did I talk about? Cosine of 2 pi over 3? And we plugged that into our calculator, right? You got negative a half? All right, well, where's 2 pi over 3? Draw your triangle. See if you can understand why the cosine of 2 pi over 3 is negative a half. We're sticking with these second quadrant ones, but we'll start throwing stuff at you all over the place. Pi over 3 is 60 degrees. You guys told me that. That's another thing that you know, right? You can work it out yourself. 2 pi is 360, divided by 2 is pi. Divide that by 6. 180 divided by 6 is 30. Take 180 or take pi and divide it by 3. 180 divided by 3 is 60. Pi over 3 is 60. So pi over 6, 30. Pi over 3, 60. You have to know that. Okay. 2 pi over 3. Second quadrant. 1 pi over 3 less than 3 pi over 3. 60-degree reference angle, right? My tall, oriented 30, 60, 90 triangle. Cool? Longer side, shorter side. Hypotenuse 1. You guys see why the cosine of 2 pi over 3 is negative a half? Why? Because cosine is what? Adjacent over hypotenuse, right? This reference angle is all I care about if I'm talking about this obtuse angle. The cosine of that reference angle in this triangle is the same as the cosine of that obtuse angle. Adjacent over hypotenuse, negative 1/2 over 1. All right, ready? Challenge, 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 challenge. 5 pi over 4. Where is it? Label the triangle. Your homework is to complete this piece of paper, not the piece of paper that's labeled homework. You got it? I will put a video together of this. If you guys can do this, next class is a piece of cake. Okay? Hey, Guzman, where's 5 pi over 4? Third quadrant, what's the reference angle? What's the side length? Root 2 over 2, root 2 over 2. I almost love it. I like it. It's really good. Negative, because I'm going to the left on the x-axis. Negative, because I'm going down. 5 pi over 4. 4 pi over 4. Add a pi over 4. You finish this for your homework. The video is on this.